Hello, welcome to my channel. Today we'll do some problems on diagonal scales. So in the previous class we have discussed about plane scales. We have solved some 4 problems on plane scales, that is in metric system for linear measurement and also British system for linear measurement. So today we'll see diagonal scale. So a diagonal scale is used to represent 3 consecutive units, that is main scale and immediate 2 subscales. Example, if you take, so kilometer is the main scale and its 2 subscales are hectometer and decameter. If you take meter, decimeter and centimeter, it's 2 subscales. So in British system, if you take yards, feet and inches are its subscales. Okay, so in this diagonal scales also, if we want to construct a diagonal scale, we need to find out again 2, that is number 1 representative fraction and number 2 length of scale. The problem is like this: the distance between 2 points on a map is 5 centimeters. The real distance between them is 20 meters. Draw a diagonal scale to measure up to 60 meters and show a distance of 43.6 meters on it. So this problem also will come under diagonal scale. Okay, so here we need to mark 43.6 meters. 43.6 meters. So here 43.6. Okay, 40 is main scale, that is meters, and its subscale also in meters, that is 43. 40 plus 3, 43. And 6 is its further subscale. Its further subscale, that is decimeter. Okay, so 43 meters and 6 decimeters. Why? Because we have a decimal point after 43. So 43 meters, 6 decimeters. So 40 meters and 3 meters. After that we have a decimal point. Then we have the next number, that is its further subscale, that is 6 decimeter. 6 decimeter. Okay, so before going to start the problem, do like, share and subscribe my channel. So again here also we need to find out representative fraction. Representative fraction, RF. RF in the problem is not given. He is saying that the distance between 2 points on a map is 5 centimeters. Say it is A and next point is B. Point A and point B is specifying that with 5 centimeters. The distance between 2 points on a map is 5 centimeters, but its real length is 20 meters. Its real length is 20 meters. As we know that RF is equals to assumed distance divided by actual distance, or assumed length by actual length. So assumed will become 5 centimeters and actual will become 20 meters. So we can write here RF can be written as 5 centimeters divided by 20 meters. Okay, so we can convert this as 5 centimeters divided by 20 meters. So 1 meter is equals to 10 decimeter. 1 decimeter is equals to 10 centimeters. So 20 into 10 decimeters into 10 centimeters. So we'll get RF as 1 by 400. 1 by 400. 1 by 400. And next we need to calculate length of scale. Length of scale. Length of scale. That is LS is equals to, we know the formula, RF into maximum distance or maximum length. Maximum distance or maximum length. So already we have calculated RF, that is 1 by 400. 1 by 400 into what is the maximum distance? Maximum distance, the problem is given as 6 meters. Okay, so 60 meters. Okay, so 60 meters. 60 meters. Already we have converted 1 meter is equal to 10 decimeter, 1 decimeter is equal to 10 centimeters. So we can write this as 1 by 400 into 60 meters into 10 decimeters into 10 centimeters. So we'll get length of scale as 15 centimeters. 15 centimeters. Now we'll draw the diagonal scale. So the length of the scale is 15 centimeters. 15 centimeters. Okay. And we know that its height is, scale is 40 mm. Height of the scale is 40 mm. Okay, and we mention this as 15 centimeters. Centimeter. Now you divide this into 6 parts. Already the maximum distance in the problem is given as 6 meters. So only we divide 6 equal parts. Why? Because in the problem it is given as 43.6 meters. So we need 40 meters and 3 meters. That's why what we are doing is we are dividing this 15 centimeter line into or scale into 6 equal parts, so that we can write it as 10, 20, 30, 40, 50 and 60. Okay. So take with some convenient radius. We are 1 same radius, 2 same radius, 3 same radius, 4 again, 5 and finally 6. So mention it as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Now we join the end points with the help of your mini drafter. You fix it with these 2 points. Fix your drafter and go on, draw all equispaced parallel lines. Move to the next point. So now you mention here as 10, 20, 30, 40, 50 and 60. Right? Now you divide this, you draw all vertical lines from these points. 10, 20, 30, 40, 50 and 60. So this is meter scale. So you mention here meters. Mention it here. Meter. Okay. So now here we have 10 meters. So what is the marking distance? It is 43 meters. So the subscale also will be in meters. That is 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10 up to 10. That will be also in meters. So you divide this 10 meters into 10 equal parts. Okay. So with some convenient radius, you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 10 dash. So now you join 10th point and the end point with the help of your mini drafter. You fix the drafter and go on, draw all the lines from the next points. So this is 2, 4, 6, 8 and 10. So you draw all diagonal lines. You join with the corner with first point and draw a diagonal line. Fix your drafter, move to the next point. Like this you draw all the lines, so you'll get all diagonal lines. Okay, so this is also meter scale. This is also meter scale, so mention it here. And then you mention RF. Here also write down. Scale is meters and RF 400. Okay, so already we have shown 43 meters, 40 meters, 3 meters. So main scale is this and subscale is this. Now it's further subscale. Again you divide this into meters, 40 meters, 3 meters. So main scale is this and subscale is this. Now it's further subscale. Again you divide this into 10 equal parts. 10 equal parts by same line divide method with convenient radius. One, 2, 3, 4, 5, 6, 7, 8, 10. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 10 dash. Now you join the end point. Join the end point. Fix your drafter. Move to the next point. Next point. Next point. So we have divided this also into 10 equal parts. Say this is 2, 4, 6, 8 and 10. Now you draw all horizontal lines. Horizontal lines. So that is from point 10. Move to the next point. So we have drawn all horizontal lines and this is decimeter line. This is decimeter. So mention it here, decimeter. Decimeter. Okay, now marking distance. Marking distance is 43.6 meters. So 43 meters, 6 decimeters. So already we have here 40, right? So already know graph plotting, x-axis, y-axis. Similar fashion, we have to mark the distance, that is 43. So 3 meters. So 2, 4, in between 2 and 4 we have 3, that is a line, diagonal line, and 6. So 2, 4, 6, 6. So just it is similar to now plotting a graph, right? So here it is 3 and 6. So this is the point. This is the point. Okay. So now from here you draw a vertical line and mention the distance. Mention the distance. So this is your 43.6 meters. Okay, so this is the problem in diagonal scale. Okay, in the next class we will see one more problem. Thank you.